All right, as we start our well, for us, it's our last week of class here total, and our last speed drill for the school year, Speed Test 50. So get your speed drill booklets out. Turn to the very last written page, not the blank page. Speed Test 50 of 1.5 minutes. It's just signed numbers. Don't mess this up. Think through your rules. If you're adding class and the signs are the same, add and keep the sign. If the signs are different, subtract and keep the sign of the greater absolute value. If it tells you to subtract, add the inverse, because we don't subtract. In multiplication or division, if the signs are the same, it's positive. And if the signs are different, it's negative. You have 1.5 minutes, Speed Test 50. Go. Stop. All right, put down your pencils. Go ahead and have pencils off your desks. Pens out. And exchange with the person behind you, person in the back. Bring yours to the front. Exchange with the person behind you, person in the back. Bring yours to the front. Sign your name at the bottom of the page as the grader for the final time this year. All right, these are 10 points each. 10 points each. Number 1, negative 15. Negative 15. Number 2, negative 14. Number 2, negative 14. Number 3 is also negative 14. Negative 14. Number 4 is 36. 36. Number 5 is positive 30, or they could just say 30. Number 6 is negative 11. Negative 11. Number 7 is positive 3, or they could just say 3. For number 8, positive 13. Positive 13. Or just 13. Number 9 is positive 6, or just 6. And number 10, negative 20. Negative 20. All right, put the score in the score blank. And then, for the final time this year, turn to the score page, put in that very last blank next to where it says Speed Drill 50 as we conclude our year's worth of speed drills. All right, return the speed drill booklet to the owner. Person in the front, take it to the back. Everyone else pass it forward to the person in front of you. Take a look at your scores. How many finished the year with 100 on the last speed drill? How about 90s on the last speed drill? 80s on the last one. All right, sounds like we have a pretty strong finish overall. Pass those forward, if you would, please. Pass those forward, if you would, please. Take your books out, open to page 466. Take your books out, open to page 466. Those watching on YouTube might remember me mentioning a field day coming up and a day that the students would not be in school. That was yesterday, in case you're wondering. And yes, that is why there is very little voice. I apologize for being hard to listen to. I was surprised I made it through field day. I did make it through field day, just not so much through today. We'll see how it goes. Page 466, you listen well, and I will try to be as bearable as possible. In the homework section, 1 through 20 at the bottom of page 466. I'm going to have that out as I come by and check. One of the things that we were looking at in our last lesson, we began talking about a special type of equation in which you have a single fraction equal to another single fraction, or really a ratio equal to another ratio. What do we call that thing in class?
Proportion.
A proportion. Now, we don't actually, they're not technically fractions, but they usually look like fractions. For instance, 5/8 and, 20 32nds. Right, those are equal, right? Times 4, whatever. Well, if they're ratios, which technically they're ratios, then these aren't called numerators, class. They're called antecedents. And these aren't called denominators. They're called consequents. But we pair them up differently when we put them in a proportion. We look at this term and this term, the first and the last. And they've got a particular name collectively. What are the first and last terms of a proportion called? Jalen? The extremes, because they're on the edges. Now it's easier to see, remember, if we write 5 is to 8 as 20 is to 32. Now we can see that they're on the edges, but they're called the extremes. What about these two values? The ones in the middle, the second and third terms. What are those called? Ben? The means of the proportion. And I said there's an important fact to remember that is true of any proportion, always and forever. Do you remember what it is, Michael?
The means are going to be equal to the extremes.
Well, the means themselves are not always equal to the extremes, but the
product of the extremes are equal to the means.
The product of the means equals the product of the extremes. Class, say that with me if you would, please. The product of the means equals the product of the extremes. Remember, of course, product means what, Michael?
The answer to multiplication problem.
Right, it means you multiply, right? So if we multiply the means, well, 8 times 20, class. 160. That's easier to do in our head than 5 times 32, but I think we're up to it. 5 times 32. Yes, indeed, it's also 160. So we said that if one of these numbers was unknown, for instance, let's just say I didn't know what this number was. Well, one way to solve the proportion would be to cross multiply. We could multiply 8 times the x, class, to get, and then we could multiply the 5 times the 32. And since the product of the means equals the product of the extremes, we have a little equation. Where to solve for x now, we just have to divide away the 8 from both sides, and that's writing x equals 20. Now, frankly though, sometimes a proportion like this would be easier to just be like, well, times 4, 20. But they don't always work out that nicely for us. And so for those that don't, cross multiplication can get us some pretty weird answers. Let's take a look at problem number 1 from the homework. Read that with the answer, if you would, Luciana.
A proportion consists of 2 equal ratios.
Excellent, 2 equal ratios. If you said 2 equal fractions, I'd give it to you, but 2 equal ratios is the better answer. Number 2, read that with the correct answer, if you would, please, Jalen.
The product of the extremes is the product of the extremes is equal to the product of the means.
Yeah, they worded it backwards just to mess with you a little bit there. Number 3, read that with the answer, Kirsten.
In the proportion 1 to 3 is as.
Oh, we need to review this, don't we? Yes. Okay, so it's 1 is to 3 as 5 is to 12. Let's all say that together, class. I think we could all use the review. 1 is to 3 as 5 is to 12. 15. Did I say 12?
Yes.
Let's try that again for my benefit. 1 is to 3 as 5 is to 15. Okay, so now read number 3 for us, Kirsten, with the answer.
In the proportion 1 is to 3 as 5 is to 15, 1 and 15 are called the extremes.
Excellent. What would be the means of that proportion, Ben?
3 and 5.
The 3 and 5 question.
Yeah. How do you know which one is the extremes and the mean? Because you just said that
Well, then we kind of count this way. 1, 2, 3, 4, right? 5 is to 8 as x is to 32. So 1, 2, 3, 4, the first and fourth are the first and last. That makes them the extremes because they're on the edges. The second and third are in the middle, so they're the means. Good question. Let's take a look at our proportions here. Number 4, they wanted to identify what are the means, what are the extremes. Bryson, number 4?
The means are 7 and 42, and the extremes are 40. No, I flipped it. The extremes are 7 and 42, and the means are 42.
There we go. The means are the 14 and 21. The extremes are the 7 and 42. Number 5, Corey.
The extremes are 1 and 48, and the means are 6 and 8.
There we go. We got means of 6 and 8, extremes of 1 and 48. Number 6, this one we could do using the equal ratio method. We don't have to cross multiply, but for practice sake, what would we get if we cross multiply, Joel?
26.
Well, I didn't ask for the answer. What would we get if we cross multiply? What would the two things say?
6x equals 12 times 13.
Which is?
156.
There we go. And then we divide both sides by 6. We do get what for our answer?
26.
X equals 26. Now that said, if there's an easy way, just be like, yeah, times 2, y'all. 26. Take the easy way, right? But it's not always there. Number 7, what would we get if we cross multiply, Michael? On number 7, what would we get if we cross multiplied that proportion?
300.
Not asking for the answer. What would we get, Michael? Multiply the extremes. What do you get?
I have 250.
Michael, number 7, multiply the extremes. Class, 100x. Now, multiply the means, class, 300. And we know that the product of the means, class, equals the product of the extremes. So when we cross multiply, Michael, we get 100x equals 300. Now, when we solve, we get what for our answer, Michael? 3. There's our answer. When we divide away the 100 from both sides. Now again, you could look the other direction. So you divide a 5 out of the bottom and top this way to get the 3. But number 8, it ain't gonna work that way. You're gonna have to do it the cross multiplication way. Then, what do we get on number 8 if we cross multiply the means?
18x.
18x. And we know that's gonna equal the product of the extremes, which is 120. Now to solve for x, what do we have to do, Ben? Divide away the 18 from both sides. Now strategy tip, class. 18 is an annoying number to divide by, right? Do y'all see the 6 head up? Do y'all see the 6 in both numbers? I can make it a 20 divided by 3 instead. And in fact, that's your answer. Or you could say 3 goes into 26 times with 2 left over. You could do 6 and 2/3. I'm cool with 20/3, remember, the improper fraction. How many have one of those two answers on number 8? Questions on 8. Yes, ma'am.
Somehow I got 6.6.
Well, 6.6, well, 6.6 is wrong, because that's 6 and 6/10 or 6 and 3/5. But 6.6 repeating would be right. I loathe and despise repeating decimals as answers. I'd rather see the fraction form.
I put it at 6.7.
Well, but it's not, because that's 6 and 7/10. It's 6.6 repeating. I just don't care for that answer. I give it to you. It's not, this is not wrong. This is wrong. This is wrong, unless it said round. If it said round to the nearest 10th, it's not wrong. But yeah, just reduce the fraction down would be the easiest way to go there. Number 9. What do we get when we cross multiply? Kirsten.
19x equals 114.
114, you said? And we have to divide both sides by 19. And it's like, oh my goodness. Well, if this were a 20, how many times would a 20 go in?
No. 5.
5, okay. So let's try a 5. 5 times 9.
45.
5 times 1 plus 4.
9.
And when we subtract, what do we get? Anyone?
9.
And then 10 minus 9.
1.
Oh. Well, if the remainder is 19, then class, that means it actually goes in evenly
6.
6 times. There's the one more. And it comes out evenly. Who knew? X equals 6. Somebody got 6. You figured it out. Good questions on that. Did anyone say there's no way this reduces? I'm going to leave 114 19ths. I don't blame you, because we didn't memorize our 19 times tables. And 19 being prime, you're like, well, there's nothing that can come out. But there was the 19 that could come out. Tricky people on number 9. Let's just go over answers here on the next row. Number 10, what was your answer, Bryson? 15 fourths, or 3 3/4. Number 11, but I like 15 fourths because I'm lazy. Number 11, Corey. 20. That one worked out pretty nicely. Check that. Number 12. We need to go over this one. That ain't nasty. Go and give us your answer though, Jalen.
7.
No. I saw another hand. Somebody else was excited to give me that answer a minute ago. Elaine?
1 3/4.
It is 1 3/4. Did anyone else get 1 3/4 on that one? Just a couple of you. That thing nasty looking, isn't it? Let's take a look. 40 15ths equals 4 2/3 to x. 40 is to 15 is 4 2/3 is to x. Well, we cross multiply, right? This ain't hard, right? 40 times x, class.
48.
And the product of the extremes equals the, oh my goodness. Now, 15 times 14 thirds. We'll put 15 over 1. Now 15 and 3 can cancel, class.
5 and 1.
And so I can get 40x equals
70.
70. Well, divide both sides by 40. Knock off the zeros. There's our answer, 7 fourths or 1 3/4. Either answer. So when it's got some weird mixed number, before you cross multiply, just show the multiplication, but make sure this becomes improper before you try to do it. Does that make sense? So then, as we look, well, number 13 was another easy one, bless you. Number 13, Luciana.
X equals 22.
Yeah, 22. That one worked out pretty nicely. I didn't think that 14 was too bad, Griffin.
X equals 16.
It did give you a little trouble, though. What did you get when you cross multiplied? What were your 2 cross products?
16x and 164.
Good. Okay, so you started off great, right? 16x equals 164. Divide both sides by 16. How many times does 16 go into 16?
Once.
Once. There we go. With nothing left, right? How many times does 16 go into 4?
None.
None. With how many left then? How many left? It goes in none, so all 4 left. Yeah. 16 can't go into 4 at all, so obviously all 4 are still left. Right? For instance, if you go to the store, you got $4, and you wanted to buy a football, and the football costs $16. What do you walk out of the store with? $4 and no football, right? So we walk out with no football, but we still have $4 left. So we get 10 and 4/16, which reduces any 1 to 10 and 4. Should have a better answer on that one there.
No.
Let's go back to Griffin for redemption, number 15.
X equals 1.
X equals 1. That one not bad at all. Then we come to another annoying one, number 16. Well, Kirsten, start with the means.
I didn't do this right.
Well, let's do it right now. What do we get when we multiply the means?
9.
On number 16, 14 times x.
14.
There we go. And then we've also got to multiply the 56 by, and it says 2 and 1/4, but Kirsten, I ain't doing 2 and 1/4. 9/4. And I can put this over 1, and I can do a little canceling, because 4 has a 2 in it, and 56 has a 2 in it. Cut it in half. 2 is in 5.
2, 5, 4, 2.
And 2 is in a 16.
16, 8,
Oh, well, I can take out another 2 to get 1 and,
7. Or not 1 and 7, but 1 and 14.
so I end up with the 14x equals, well, what's 14 times 9?
Um, 30, not 36.
Well, 36 carry the 3.
126.
And if we have to divide the 14, we're like, wait a second. Where did I just get 126 from? 14 times 9. So if I'm dividing 126 by 14, I'm of course going to get 9. There we go. By the way, shortcut, we're like, wait a second, there's a 14 sitting over here. Y'all watching? Instead of multiplying 14 times 9, just leave it. And we divide the 14. These 14s cancel. Those 14s cancel. X equals 9. Lazy. Big fan. How many got 9 on number, whatever that was, 16? Questions on these proportions? Yes, sir.
So, on 16, for the last answer, I put 17 over 14. I meant 117 over 14.
Oh, you just multiplied wrong then. It was 126 14ths, and then that actually divided out evenly. Let's go to number 17, Ben. Let's start with the means, or the extremes rather. Let's do the easy part first. What do we get when we multiply the extremes on 17?
8x.
8x. And rather than actually multiplying right now on those means, I'm just going to leave it as 90 times 4/9, right? But let's put the 90 over,
1,
and that allows us to do a little canceling, Ben.
1 and 10.
And then we know that, well, 10 times 4,
40.
and that allows us to divide both sides by,
5.
well, by 8 to get x equals
5.
5. How many had 5 for your answer on number 17? Do we see how to handle fractions? Don't try to do them in your head. Just write it out and do what you normally would do with fractions. Questions on those? Out of curiosity, we didn't do a lot of practice with proportions in class. You had 9 of them, or 12 of them here. Was anyone 12 for 12 on the proportions? Wow. How about 10 or 11 out of 12? You only missed 1 or 2 of them. That's really, really good. We'll practice more with that a little later on. Quick question? I thought I saw you, Joel.
What was 15?
Sorry.
What was 15?
1. Right, any other questions? Let's drop down to the bottom. Some really easy equations here. What'd you get for number 18? Joel?
-2.
-2 is correct. -2. Let's try that again. Number 19. What did you get for your answer, Bryson? 7 tooths, 7 halves, or 3.5. And but I like 7 halves. And number 20. What did you get, Jalen?
9.
9 is correct. Questions on the homework? Yes, sir.
So, 19. I
Yes.
got 14 over 4.
Ah, okay, careful. Oh, well, yeah, you're not wrong. 14/4 is correct for y. Just divided 2 out of the top and just reduce it down. And that's what we get 7 halves. So on the quiz or test, minus a point. You just didn't reduce, but you got the right answer. The process was correct. Good. Other questions? Yes, sir.
The 19 with 14 over 4 would be right.
I'm sorry?
The 19 with 14 over 4 would be right.
That's what he just asked. I said it'd be minus a point if you didn't reduce.
Oh.
Right, good question. All right, other questions? All right, look up at the top of the page. In the review section, do 42 to 49. Do 42 to 49. Let's practice 8 more of these proportions and see how we do. Let's do 8 more proportions, see how we do. We got a chance to practice it, went over it. Now let's see if we got a little better grasp of these proportions, though it didn't seem like we did too bad on the homework anyway. So off to a good start. I missed one. Oh, that's what I missed. All right, for sake of time, pencils down. Even if you're not finished with all 8 of them, that's fine. Check the ones you did get done. And on our very first problem, we cross multiply 18x equals 60. We divide both sides by 18. I think we can skip showing this step. I really do. I think we can just tell ourselves, look, we know we're dividing 18, just write it as the answer, 60/18. Just, it reduces by 6 to get 10/3. How many got 10/3 as that answer? Or 3 1/3 would be fine as well. Look at the next one. Cross multiply 30x equals 12. Again, you're dividing by the 30, so you get 12/30 well. Again, reduced by 6, 2/5. How many got 2/5? There is a shortcut. Look at this, 3/30. Thoughts? If instead of working with big numbers, you can work with little numbers. 10x equals 4. Then x equals 4/10. Still becomes 2/5, just makes a little smaller numbers. Did it save you any steps? Not really, but it gave you little numbers. And as a lazy mathematician, I like little numbers. Look at this next one. That's awful, isn't it? What could you reduce 27/45 by, class?
9.
9. To get x is to 15 as
3 is to 5.
3 is to 5. Now all of a sudden, if you cross multiply, you got 5x equals 45, x equals 9. Isn't that easier? So, tip to carry with you as you'll do homework tonight with proportions, reduce ratios down if you can first. Just makes easier numbers. Here, you didn't really have that option, but you could have said times 4 to get you 28, or cross multiply as I showed. How many had 28 for that one? Here's another candidate for reducing. 24 is to 6. Not 24 to 6, class.
3, 4 to 1.
4 to 1. And suddenly now, 1x equals 52, and you're done with the problem. Reducing ratio is going to save you so much time. Now this one, well, times 12 going this way, times 12 going that way. Could work, or do like I showed. Here, we just kind of had to play with it, didn't we? Like, we just kind of stuck. 8x equals 25 times 3/5. Cancel the 5, 25. 8x equals 15. 15/8. 1.875. 1 7/8, whatever. Those who made it this far, how many had 15/8? And the last one is ugly. 9x equals 77. 77/9. I'm done. Or 8 5/9, or 8.5 repeating, but I'm good with 77/9. How many got all the ones you did correct? If you're going to get them all done, all the ones you did were right. Okay, questions on any of them now that I've talked them through? Yes, ma'am.
On number 1, if you put 3.3 repeating.
That's fine. Yeah, it's fine. I don't like it, but it's not wrong. Yes, sir.
So still on number 1,
Right?
I put 20 over 3.
Oh, so you reduced here by 6 to get 3, but you've reduced here by 3 to get a 20 then. Okay, so just make sure what we divide out of the bottom is what we also divide out of the top. Just make sure we take the same thing out of both. All right, good. Other questions? All right. Flip over now to page 468. Flip over to page 468. And some quick questions here. Number 1, read the question, give me the answer, Joel.
What is the name of 2 ratios that equal to each other?
Read it nice and loud so the camera can hear you.
What is the name of 2 ratios that equal to each other?
And what's the answer?
Proportion?
Proportion. Very good. That's what we're just working with. Number 2, read the question and the answer, Michael.
When solving an equation,
Watching the rules must be followed to keep the equation balanced.
I'll start it off. What you do to one side,
Yeah,
there we go. That's the general rule. To keep it balanced, to make sure you don't shift the equality at all, what you do to one side, you gotta do to the other. Number 3, read the question and the answer, Ben.
The algebraic method solves a proportion.
What do you do to solve a proportion, Ben?
Cross multiply.
Cross multiply. There we go. Or if you're trying to name it, cross multiplication, we do say cross multiply. Number 4, Corey, read the question and the answer.
In the equation 4x negative 5 equals 11, which probability should be used first?
In other words, what should you do first?
Put a positive 5 on both sides.
Good. Add 5 to both sides, or put positive 5 on both sides. Number 5, Bryson.
What equate in the equation?
Nice and loud.
In the equation 6y plus 8 equals 4 negative 6. What should we do? What should be done first?
What should we do first, Bryson?
Subtract or like add negative 6 plus 4.
Good. Add the 4 and negative 6. Simplify that right-hand side. Let's get just a single number over there before we start getting the y by itself. Good. Look across the page, page 469, number 22. At your seats, read it, write the equation, solve the equation. Number 22. Read the equation, or read the problem, write the equation, solve. Go ahead and read it aloud for us, Griffin.
4 times a number increased by 5 is 25.
What was your equation?
4x plus 5 equals 25.
And when you solved, what did you get for x?
X equals 5.
So what's your number?
5.
5. That's the answer. There we go. How many had the same equation? Same answer. Excellent. Number 23. Read it to yourself. Write the equation. Solve. It's just drugs. Don't worry about it. All right. Kirsten, would you read the problem aloud for us?
A recent traffic study found that 2 more than 3 times the number of cars pass through intersection A than intersection B. If 50 cars pass through intersection A, how many cars pass through intersection B?
All right. Now, how many unknowns are referenced in the problem?
2.
2. Now, one of them isn't really an unknown, but there are 2 things referenced. We've got intersection A and intersection B. Which one do we actually not know, though?
B.
We don't actually know B, so we'll call B B. But we do know intersection A,
50.
50. But the equation tells us that 2 more than 3 times the number of cars pass through A than through B. The number of cars through A was 2 more than 3 times the number through B. What's our equation?
3B plus 2 equals 50.
Good. The cars through A are equal to 2 more than 3 times the cars that went through B. How many have that same equation? And when we solve, what do we get for our answer, Kirsten? She does not have it yet, Jalen? 16. There we go. 16 cars through intersection B. Questions on number 23. That was a little bit more tricky than the last one. Let's go to number 24. Read the problem. Set up the equation and solve. Very similar to the last one. It feels like 2 unknowns, but Jalen, there's really only one. Bowls. We don't know bowls, so we could call it M. But we do know plates. 24. The number of plates is 24. But then it compares the two. It says that there are 10 more plates than twice the number of bowls. So what's our equation? Perfect. The number of plates is 10 more than twice the number of bowls. How many have the same equation? When we solve, Jalen, what do we get for the number of bowls? 7 bowls. How many also had 7 bowls? All right, questions on that one? All right, read number 25. Read number 25. Write the equation and solve. Do we realize this time there are 2 actual unknowns? I don't know either Josh or Dad, do I? So I've got to look for the comparison. I've got to look for the comparison. Who does it come back to at the end of the comparison class? Dad. So Dad gets to be X, or whatever letter you pick. But how would I represent Josh, Elaine?
X plus 1.
Josh is 1 year older than his dad.
X minus 24.
X minus 24, because he's 24 years younger than Dad. How many had Josh as X minus 24? All right, those who did it, does it make sense now? Now, what's the equation, Elaine?
2x minus 24 equals 40.
There we go, because it said that the sum of their ages, X minus 24 plus X, Josh plus Dad equals 40. Elaine realized that 2 x's are just going to make a 2x here. And so when we add the 24, we divide by 2, we end up getting here, class, that x equals?
32.
Well, 2x equals 64. So that means x is equal to 32. So how old is Dad?
32.
How old is Josh?
8.
8. Because 32 minus 24 is 8. And sure enough, there's the sum of their ages. How many had that? Jump over to 27. Jump over to 27. Right between Allie and Earl. And Earl does not like being beat by a girl. His face says it all.
I feel that.
Yeah. Somebody with a slightly older sister. I was the same way. My older sister was 4.0, straight A pluses, valedictorian, summa cum laude, all that stuff, and she was 1 year ahead of me. I'm not gonna lie, that's what drove me to achieve the same things, because I'm like, no, I know I'm smarter than my sister. I refuse to be beaten by her. Now, she went and got her master's degree. I ain't done that yet. But I'm like, that's a lot of money in 2 more years of school. Yeah, okay, you have your master's. Okay.
I will not be beat.
Like, I will not be beat by my sister. I love her to death, but I will not be beat by my sister. Love you, Melissa, if you're listening out there.
I didn't know you had a sister.
I have 2 sisters. All right, let's take a look at 27. Obviously, Allie and Earl are the 2 unknowns. We don't know either one of them. Which one gets to be X in this problem here, Luciana? Earl, because that's what it comes back to in the comparison. How did you represent Allie? Be careful.
X plus 3.
Oh, you fell into the trap. You saw 3 more than, you assumed it's X plus 3, but read carefully. 3 more than,
Twice.
So
B plus, well, X plus 3.
3 more than twice. What would be twice?
2.
2X. But 3 more than that would be,
2X plus 3.
there it is. How many had Earl as X, Allie as 2X plus 3? 3 more than twice as many. Questions? All right, what's the equation? Because here we got to be careful as well. Luciana, what's our equation?
2X plus 3 plus X equals 7.
Okay, because it said that the,
Difference?
oh, wait a second.
Yeah.
Difference. What does difference tell us to do?
Subtraction.
We actually have to subtract the 2 unknowns here. So you put a couple twists in this problem, which is why I want to look at it with you. First of all, they have 3 more than twice, so we had to pay attention to that detail. And I said the difference of the number of fish that they caught was 7. How many had that equation correct? All right, questions. Walk me through solving it now, Luciana.
So subtract X from 2X to get 1X plus 3 equals 7. Then subtract negative 3 from both sides. And you get 1X equals 4.
All right, so who caught 4 fish?
Earl.
Earl had 4. Not a bad day's haul until you see that your sister has 11. And suddenly, your 4 seems very disappointing. Questions on that? Yes, sir.
I saw, after I did the problem, I saw the difference, so it wouldn't go like, I put it as negative, I put negative 7 instead of minus negative.
Now, the difference tells you what to do with the 2 unknowns,
Okay.
right? So if it said sum, we would add. If it says difference, we would subtract. If it said product, we would multiply and stuff like that. All right, clear desk except for a clean sheet of paper and a pencil. We will take our final quiz of the school year. Clear desk except for a clean sheet of paper and a pencil. Everything else away. All right, for those watching on YouTube, this is quiz 43. Quiz 43, our final quiz of this school year. First last name at the top of your paper along with today's date, which is 5/16/24. First and last name, 5/16/24, today's date. All right, once you got that on the paper, let's go and take a look at the quiz together. Look at the front side of your quiz. It's just all equations, really straightforward. Be careful as you solve these equations not to make careless mistakes. Careful not to make careless mistakes as you're solving these equations. Turn the quiz over, if you would please. Notice on the back side, we've got 3 word problems for you to solve. There are 2 blanks. The first blank on each word problem is where your equation is going to go. Do all the work down below the word problem, but make sure the equation goes in blank A. Blank B is the answer that they're asking you to find, or perhaps the answers they're asking you to find. All right, I'm going to write the homework on the board. You can go get started on that quiz. And I'll end the video here, and you can copy down that homework.